Okay, this is chapter 2, in which we will go over the database languages and architecture in general, and the outlines and the headlines of this chapter include data models, schemas, and interfaces, and also it contains the three schema architecture and data independence, and we will shed lights on database languages and interfaces and database system environment. We will also consider the centralized and client-server architecture for database management systems. At the end, we will classify the database management systems in different categories. The basic database management system architecture, we can call it client-server. That means client and a server, client module and server module, in the sense that a server module. It concerned with computers that stores the data and provide access to the data, so provide resources to the clients. The clients are computers that request information from the server and access the server remotely to get the information according to the privileges that has been assigned to the client. The data models, schemas, and instances include also a lot of concepts. One of them is called data abstraction, data model, and dynamic aspects of the data model and stuff like that. So a data abstraction simply is they look at it as separation of details. Separation of details of data organization and storage means you limit the details. You don't show the details, rather you show the big picture of the organization, the main idea, the data abstraction. It highlights the essential features to for the understanding of the database rather than the inner details of the database itself. A data model, what is a data model? A data model is a collection of concepts, different concepts that describe the structure of a database and provide kind of understanding to achieve such abstraction. It includes basic operations of the that can take place in the database, like to specify the retrievals of the database, queries, updates, that can be done, the operation, basic operation that can be performed on the data. Also, it can include dynamic aspect or behavior of the database application, which allow the database designer to have some operations that is allowed on database objects. There are a lot of database objects that can have these dynamic aspects on them. These database objects could be a table, could be a view, could be a query, a report, a form. So there is some behavioral, aspect or dynamic aspect, which is usually requires the user interaction. But the main categories of data models can be divided into high level, low level, and representational models. The high model is the way people perceive the data. The high model is the way that many users look at the data from their own point of view. But the low level is the physical model, or the physical data model, which describe the information, the detailed information on how this data is saved into the computer storage media or in the database. So I would say that high level is conceptual, while low level is physical. Conceptual is the understanding how the whole idea of the database itself look like, or the database entities, how they look like in the eyes of the users, while the physical or the low level is the representation of this view in actual data system like database management system, how it is stored in the database management system. And the representational data models, because it contain actual data for testing reasons, so it is very easy to be understood by end users. These data models, they represent the mini world. They represent the actual institution or the organization this data serves. So it is similar to how data are organized in computer storage as well. So it is kind of logical, rational, and easy to use these kind of data models. So these are three different data models in general. In details, we can talk about these data models in terms of some concepts that needs to be explained, like entity, attribute, relationship, and then relational data model, and also object data model. All these concepts are part of the database models. Entity represents a real world object or concept. Anything can be regarded as an entity, like a computer can be regarded as an entity, a student, a course, an instructor, a section. All these are examples of entities. Attribute represents some property of interest which describe that entity further. So anything describe the entity, like a student, for example, is an entity. What describes the student? A student ID, student name, student phone number, student email address, and student grade, section, course, program, or major. All this information that describe the student are called attributes. We call them attributes. We can call them properties. We can call them characteristics. All of them serve the same objective, which is a description of these entities. Also, relationship among two or more entities, which represents some sort of association among entities, yani the relationship between entities. If we consider the relationship between instructor and student, for example, so the relationship is mutual, exclusive. That means a student takes a class taught by that instructor, and an instructor teach these students a specific course. The relationship between a student and a course. So a course is taken by a student, and a student is taking that course. So the relationship is mutual between these two entities. There could be a relationship between more than two, or the relationship between instructor and student and the course. So an instructor is teaching a course, or conducting a course, or delivering a course, and at the same time instructor is teaching the student. The student is taught by an instructor, and the student is taking a course. The course is taught by an instructor, and the course is taken by a student. So the relationship, we will talk about the relationship in details, but it is something or called association among entities. We explain this through something called entity relationship diagram. ARD, or entity relationship diagram, is a tool that we can use to explain such kind of relationship between entities, specifically in the relational data model. The relational data model itself is not new. It's been there since early 1970s, and it is the most common data model used frequently in traditional commercial database systems, but it is common now in business compared to the traditional data model or the object data model. Traditional data model has a lot of different issues, as we will know later, which is traditional data model is a file system model where all information are kept in one container, which has a lot of different problems like redundancy and inaccuracy and confusion, and a lot of different problems, of course. Object data model is kind of a new family of higher level implementation data models, but it is developed this model to take care of the new, more complex data types. Unfortunately, a lot of organizations will not be able to or cannot implement this data model because it is more expensive, more complex in terms of cost, time, and training of programmers, designers, and also the transformation of database systems from relational data model to object model is very costly. Also, we have the physical data models which describe how data is stored. Physical data model, as we explained before, is opposite of conceptual data model. The conceptual data model is how the main or the big picture look like, but physical data model how the data is stored as files or tables in the computers. We can also use what we call access path, which is something that make the search for specific data more efficient and easy, like indexes, for example, which we can use them as an example to access the database more easily and more quick, because it allows for direct access to the data using an index or a keyword. For example, I have a book here and I would like to look for a specific word. So I have a book here and I would like to for example search for something. So I would like to search for arrays, the word arrays. So what I have two options, of course, because I don't know what is the first occurrence of the word array. So what do? I have either to start from the first page, scanning page by page and line by line, word by word, until I find the first occurrence of the arrays. Or the most, every book author has made it easy for us by putting index at the end of the book. Like the indexes, you will see that starting with letters A, B, C, D, E, F until the last letter Z. And then I would like to look for this word arrays. Then I can open the letter A, and then until I find the word arrays. And here I can find that the word arrays is in page 271. Okay, so I go straight, instead of scanning the first 270 pages, I will go to page 271, because that is the first occurrence of this word, and I will find the statement why this word is mentioned. So this is an example of easy access path. In database, we have the same thing. We use some keywords or terms or indexes in order to access the data base tables more efficient. The database schema, as I mentioned before, is a diagram. The database schema is actually the description of a database itself, but it can be represented by a diagram called the schema diagram, which displays the selected aspects of a schema, which include the entities, the relationship between them, the attributes, and the constraints maybe, and if there is any other thing involved, like business rules or something. And the schema construct is each object in the schema can be considered as a schema construct. Also, database state or snapshot or state, if the data resides in database at a particular time, what is available in the database at a particular time is called database state. It could change it could change from one time to another, but it is the the state of the database is at a specific particular moment in time. This is its state. Let's call it the state of the database, which is the current available database before any modification or update. This is an example of a database schema, although it is not complete because it has only two things here. We can see the entity names like student, course, prerequisite, section, and grade report, and we can see also the attributes of each entity. Like for example, course has 5 attributes: which course, name, course number, grade, hours, and department. But the schema could include more than that. It could include the relationship between these entities represented by lines or arrows, and also it can include relationship names as well, and if there is any constraints or something like that, you can actually include in the diagram. But this is a simplified example of a schema diagram for a database, college database. We can also define a database by creating it, by specifying the database schema to the database management system. So if we create it, if we decide on it, then we are actually defining the database. And the initial state of the database, initial state means the actual, as I mentioned before, the populated or the loaded data with the initial data. For example, I have students registering in my course CS350. Okay, so the table of these students registering in that course have been populated on August 30 by 28 students. This is the initial state, the actual state of the database. But what is the valid state? The valid state is after some students drops or withdraw from this section, from this course, then this data available constitute the valid state, which is satisfy the structure and constraints specified in the schema at that particular point of time. So the valid state is different from the initial state. Initial state is the data might be actually uploaded to test the database system. Also it is called initial state. Schema evolution, it talks about changes applied to the schema as application requirements change. Since the application requirements will change, then you can change the schema accordingly. So we call it evolution of the schema or improvement of the schema, because sometimes some user requirements can change. If the user requirements change, then automatically the schema will change according to the user requirements. Then in the 3-tier architecture and data independence, we can talk about 3 different levels: internal, external, and conceptual. And this level is internal, as we mentioned before. It describes the physical storage of the data, whether it is a metadata like data dictionary or the actual data, while conceptual level describe the structure of the whole database for community of users, different users, whether they are users that are simple users or database administrators or designers, programmers, anyone who is involved in the process of this database is considered a user. So we have a wide variety of users who can deal with this database. So the structure that describe this, describe this process is called conceptual. It is actually explained in the conceptual level. An external view level, external or the view level, it describes a part of the database, that a particular group of user is interested, not the whole database, which is part of it, part of the database. So database can be extracted in queries or views, or created through specific application in forms or reports. So this external view is the applications that can be created out of this database, queries, for example, or reports or forms that have it has interest for a specific group of users. The diagram that describes the three schema architecture and data independence can be seen like this, which is this is the external level on top, which is the end users, the external view, when they are using the conceptual level, which is the conceptual level, which is the main and the conceptual understanding of database in their views to access the internal schema. And the internal schema is represented by stored database. As I said, stored database could be actual database, actual data, or data catalog, or data dictionary, or metadata, which is a description of the database itself, how the data is stored, what does it contain, how many tables, and so forth. So also the capacity to change the schema at one level of a database system without having to change the schema at the next level is called data independence. Data independence means data is independent of applications. The data is stored in one place, and the application dealing with this data are just interfaces or application or builders in order to access and use this data. So there should be some distinction between the application accessing the database or using the database and the database itself. There is also two different types of data independence: logical and physical. Logical, when you actually represent it in data models format. Physical, when you actually store it in actual tables in the database. So what you can do logically can be reflected on the physical database. When you talk about database management system languages, we have different languages like DDL, SDL, VDL, and DML. And in database conceptual description, we can call them data definition language, DDL. Data definition language concerns with definition of the schemas and database, like creation of database, creation of tables, or changing the structure of the tables, or dropping, removing completely these tables. It's called data definition languages. The data storage definition languages, they talk about the data itself, which is the internal schema, as we explained earlier. Well, the view definition language, VDL, specify the views or the mapping to conceptual schema, how the schema look like in the view of users. Data manipulation language, DML. In DML, we mean the ability to retrieve or insert or delete or modify, update the data. There are some commands we can use in this sense, like insert delete or update, while in data definition language, the commands that we can use like create or alter or truncate or drop. In high level or non-procedural data manipulation language, this can be used to specify some complications in database operation. So some high level or non-procedural level can be specified, like using object-oriented tools or something like that, to specify some complex database operation, particularly in object-oriented languages, like using C# or C++ or Java, to create some application that need to specify some complex operation in the database. Like the low-level procedure DML, this can be embedded in the general purpose of the programming language. We can divide them into set at a time and record at a time. What is set at a time and record at a time? Set at a time means if you'd like to actually deal with the modification of database, a whole block at one time, the whole block at one time, or the whole table at one time, then we call it high level. But if you'd like to deal with it as one record at a time, like for example, a student drops a course, so we don't need to delete the entire table. We only delete that student and leave the rest of them. So this is one called one record at a time. And in the data interfaces, we have different data interfaces. Look at them. Like we have menu-based interfaces for web clients to browse a database and retrieve it in their browsers. It's called menu-based. We have form-based. Form-based means forms are created to in order to create specific application, access the database and create a specific application based on this database. It's called forms-based. Form could include command buttons, drop-down menu, include input box, text boxes, check boxes, radio buttons, list boxes, and stuff like that. Which this is application, but it is actually connected to the database itself. Graphical user interface, which could be in different format as well, like in Microsoft Access, for example, to create some sort of graphical user interface to access that database. Natural language interface and speech input and output, these are connected together because you can have some speech recognition database that when you talk in a search engine, for example, to search for a specific information, this is called the speech input and output. So you speak in Google to ask for a specific information, search for a specific information by speech, and the information you get from there is the output. You have input and output. So use natural language. Which is a branch, part of artificial intelligence as well. Like this, Google Mini devices where you can have these speakers. You talk to them and ask them questions, and they reply to you. From where? From the database. So you actually talk to them using natural language like English language or Arabic language or any other language, and then they respond to you. When they respond to you, giving you the information, they use the database. Like the example I have mentioned before, which is, I would like to know the temperature tonight in Jubail. So what I'm going to ask this device, what is the temperature? A specific question. What is the temperature now in Jubail? Then it will take that as an input, and then it will pause for a couple of seconds. This couple of seconds means it will go to check the database and see the temperature for Jubail at this moment, and then it displays the information by speech as well, by using natural language and so on. all the interfaces for parametric users as well, which is specific purpose, data used for a specific purpose of users. So users that are accessing the database for a specific purpose that concerns them, specialized purpose. Or also for database administrators, there is an interface different from that, because database administrators, they need interface that has a lot of different tools to be able to build the database, create users, change their password, give them access, maintain, make a backup and recovery and stuff like that. So these are different interfaces for database management systems. A database management system, as I said, it is a software like Oracle, like Microsoft SQL Server, or like MySQL, or even Microsoft Access is a database management system. There is old management system like Sybase and DB2 and some stuff like that, which is this old one like FoxPro, Ingres. All these are examples of database management system, and they have different interfaces. But this is a general ones. The database system environment can contain some modules like buffer management, which make it easy for people to navigate and access some frequently accessed database, store data manager, which store which contain the what's called the size of the database, and would like to divide this database among different users, give them some specific capacities. That DDL compilers, which is concerned with executing create command or delete, drop command or alter command. Interactive query interfaces, which will allow users to interact with the database for query purposes, which they have query compiler and optimizer. Both of them, query compiler and query optimizer, are part of the interactive query interface, where the user would ask questions to the database system, and the database system will analyze the request and then compile this request, optimize this request, and then display the output. We can use also precompiler. Precompiler is a software that before it compiles, it will actually classify or categorize the information that is requested by the client. The database management system component modules also include runtime database processor, which is concerned with transactions that are executed at a specific point of time. It can contain system catalog, which is the metadata, which is the data dictionary, which include information about the database itself, and also concurrency control system. The concurrency control system deals with the situation or the current situation of the database and the transaction conducted at a specific point of time. Backup and recovery system also, the backup ability or tool which enable the database management system to save information for future. And recovery is the tool that allows database management system to recover this database in case the database has been lost or damaged or broken or stolen and is not available anymore. So we can have these backup and recovery features in database management system to help with recovering the database. This is the component modules of database management system and their interaction. If you look at them, you will see that here these are the users, different users, DBA staff, casual users, application programmers, and parametric users. All these are different types of users. What are they using? They are using, for example, data definition language statement, or they are using privileged commands. Privileged commands means commands that have a specific privilege. Privilege means permission to do something. Casual users will use interactive query to just query the database, and application programmers, they use application programs in order to access the database, and parametric user, they can use the compiled transaction has been conducted, and each one of these applications can be optimized or compiled or pre-compiled, and before they can actually send it to either the database here through the query optimizer, or it can be sent to the system catalog data dictionary in order to quest information from the database or the metadata or the database dictionary. And the database is stored here, which has an input and output tool to the stored data manager. Stored data manager is the one that controls the space and the capacity of and the size of the data and the size of the data base given to specific users as well. So this is a runtime database processor, which is actually accessed both by the metadata or the stored data, and both of them, the stored data and the metadata, they access the runtime database processor, which is actually you use the database itself in order to get the information retrieved to them. So the relationship between these components of modules are working in interaction. Basically, you might not use all of them at a specific time, but at least whoever user out of these 4 different users is using, then he can actually go through these steps in order to acquire and get the transaction completed and conducted. The database system utilities can include also loading and backup. Loading means load existing data files or tables in database. Backup means create a a copy of the database, as we mentioned before, and then the database storage reorganization means you reorganize a set of database into different files organization, reorganizing them for the sake of maybe migrating from one database to another, if possible, or migrating from one database management system to a new object-oriented database system, if being requested to make this kind of transfer. Or performance monitoring means to monitor the performance of database usage and provide some statistics to database administrators on how the running of this database, how the database runs. This statistics could be done weekly or daily or monthly or at a specific point of time. So performance monitoring means monitoring the performance, which is part of database administration tools. CASE tools also can be used. CASE stands for Computer Aided Software Engineering Tools, which is a lot of tools that can be part of the application environment facilities for the database. CASE tools are actually part of software engineering for creating applications, and because the difference between database and applications is that database is actually data stored in database, and applications are some software that is created in order to deal with this database differently. Whether to deal with it as tables or as views or as procedures or functions or packages or triggers. So there is different types of objects, of course. Data dictionary, which is data repository system. This is store design, decisions, usage standards that describes the information itself. As I told you in the previous slides, that data dictionary pertains to the actual structure of the database, tables, their attributes, the size, the constraints, the relationship. So it is information about the data. We call it data about data. Also, we have some application development environments that help in application development, and also some interfaces that help with communication software, part of these applications, communication tools. Like, for example, SIS system that send SMS messages to all students. You know, it's just a button that the student affairs representative just press that button and send SMS to all computer science students, or to send them to all prep year students. So that is actually a communication software connected to the database, stored database. Centralized and client-server architecture for database. We did talk about them briefly. Centralized database management system architecture. We said all database systems actually, and application programs and user interfaces are carried out on one machine. It's called centralized. If they are carried, everything, all functionality, application programs, execution, user interfaces, and processing, if it is carried out in one machine, we call it centralized. But this is not the case in most cases. It is not centralized because the different computers can have different tools from this database management system. The physical centralized architecture look like this. You see the terminals connected through a network to application programs, whether they use application program terminal or text editors. Any one of these software of the database management system can be used to actually connect to the database management system, in which it is installed on operating system, and the operating system itself, which contain all these devices, as you could see: system bus, CPU, memory controller, disk, I/O, input/output devices. This is hardware or firmware in which we have installed the operating system, and in the operating system we install the database. And you look at it like three levels or three layers. We have the hardware itself. On the hardware we have the operating system like Windows or Apple Mac, and then on that one it comes the database management system. And then this database management system either itself can have terminals from the same computer to access the database, or it is connected through a network to different terminals, outside terminals, external level, so that we can access this database. The servers, of course, they have some functionalities, because we can have file server, which maintains the files of the client machine, or print server, which is connected to different printers. It can accept different requests by different clients and then print their request. Or web server or email servers. Email server like Outlook, for example, or web server, which is enable people to post their websites on the net. All these are called servers. Client machine actually provide user with some interface to utilize these servers, to access them and to get information from them. And then in these client machines you can only run your own local application and use this database. This is a physical two-tier client architecture, you can see that we have here, for example, I have print server, file server, and database management system server, in which they are all connected through a network to these clients, where you can access, every client can access any one of these servers. This is logically speaking, for this two-tier client server architecture. In the physical two-tier client server architecture, we can see that the server, this can be actually working as a server and a client at the same time. This computer, peer-to-peer, and this one is a server. But these two are clients. This client without a disk, client 1, and this client with a disk, and this is it could be considered as a client at the same time is a server, and because a computer could be a server and a client at the same time, they're all connected to this server computer through what is called communication network. So what does that mean? It means that a client could be a server could be a client and a server at the same time, and it can be connected to other computer. That computer that is connected to is a client, right? But it could also be a server at the same time, server for other server. Like we have a database server here, but this database server is connected to another computer that has a print server, and this server is connected to another computer, so communication network to another computer, which is called a client, but it has another web server, and so on. So this is a physical implementation of this two-tier architecture. Generally, what is a client and a server? A client is a user machine that provides user interface capabilities and local processing, and access the information and get the information, or send requests to the server. While a server is a system containing both hardware and software, and it contains the information, it contains the data, it provides service to the client machine upon request. As we said, there are such file printing, archive, or data access. There's different types of servers: file system servers or network servers. So the server, it handles the query and transaction functionality related to SQL processing. SQL stands for Structured Query Language, the question that a user asks to the database. And the client handles the user interface programs and application programs. So the user is using the interface programs and application programs to connect to the server and get information from it. There is another concept called Open Database Connectivity, which is ODBC. This is an interface, or it is a software that provides application programming interface to connect to the database, because it allows client-side program to call the database management system, and it has the software to installed in it, so that it can actually connect through a specific connection string, whether using database management system called Oracle or MySQL or any other database management system. Each database management system has its own different way of connectivity. JDBC also for Java client programmers to access one or more database management systems through standard interface. So we have ODBC or JDBC. Both of them, they are actually some application interfaces to connect to clients, to connect clients to the servers. The application server or web server, this it is actually a layer between client and the database server. It's called web server or application server, because you have the client and you have the server. Okay, the information are on the client. Who want this information? The client need the information. Where are the information? The information are on the server, how do we access this access and get information from the server, and how the client be able to get information from the server. We can use a medium, or an intermediate application called web server. Web server is helping the client in order to get access to the server. And also it can run application program and store business rules and stuff like that, and sort this information in the way that the user likes. Entire divide the layers between the user and the stored data further into finer components. So sometimes there is some servers that will divide these layers of interfaces between the user and the data into different fine components for easy access, easy transaction processing, and it's called the entire model. So we have here the client and a server. A client on top, they can use graphical user interface like web interface or presentation layer, and the server at the bottom, it could be database management system or database services layer. Both of them, they need what is called an application in between in order to communicate. This could be application, program, web server, or business logic layer in case of business applications. I'd like to classify database management system in terms of these data models. You can say the data models are relational data model, or object data model, or hierarchical and network, or native XML database management system. And the most common one, as I said, it is relational. With the more advanced is object oriented. The old one is hierarchical or network, which we are not using anymore in database systems. And native XML database management system usually used for multimedia and web applications, a huge web application like in ebay.com or amazon.com. But the most usable one is the relational data model. If you talk about number of users, we can have single user. Single user is a user that uses the database only for one person, and this database management system could be like Access program, Microsoft Access. Multi-user, that means a database management system can be accessed by different users, many users, as in case of Oracle or MySQL. Also, in terms of number of sites, we can have either centralized or distributed. Distributed, like it could be homogeneous, that has relationship between them, or heterogeneous, that means scattered around the business and there is no relationship between these different sites. Homogeneous usually is the most common, where a database is connected together, have relationship between them. Heterogeneous means data is stored, but is stored in different location and there is no relationship between them. Heterogeneous. Heterogeneous means separated. There is no connectivity or relationship between them. If it is distributed, of course, if it is centralized, it could be one centralized database system that is used for one database system in the organization, and in this case it could be homogeneous. The cost of this database could be open source. There is some database system like open source database management system, like MySQL, for example, or it has different licensing, like SQL Server from Microsoft. It could be also Oracle, but the MySQL mostly is free to use, mostly, and with little cost of maintenance. Also, if we can divide the type of access pass options, we can have general or special purpose. Yani some database system could be for general purpose, and some database system could be for a specific purpose. This is the schema in network model notation, which describes the classification of database management system in terms of entities with some relationship between them, like this in the middle, like course offering or student grades or section grades, or has a or is a. These are called relationship names. So this is a typical example of a schema that has more components than previous one. The previous one has only or has different components, I would say, not more, because the previous schema that we described before has the entity names and the attributes only that describe these entities. But this one, it doesn't have attributes, but it has relationship between them. The relationship names is written, and the arrows are connecting these entities, showing the relationship types. But a more common, a more advanced one, a more complete one, that contains both the schema name, attributes, relationship, and also if there is any constraints described for that purpose. So this is it. This is the last slide, and for this chapter. And in this chapter, we have considered the concepts used in database systems, the main categories of data models, types of languages, interfaces, classification, criteria. Also, we used data model, different types of users, number of sites, and access paths. And I hope that you review this at your own pace.